Okay, so this is lesson 2 of our virtual learning. So we're going to be adding and subtracting polynomials today. So the first definition that we have is this idea of closure and what that means to be closed under an operation. So basically, something is closed if when you perform an operation like addition, subtraction, or multiplication, then you get out the same thing. So it gives the examples of integers being closed under addition, subtraction, multiplication. Because if a and b are integers, then when you add them, subtract, or multiply them, we also get integer values. So the same thing, polynomials are closed under addition and subtraction. The sum and difference of any two polynomials is also a polynomial. So this is our main idea right here, our big idea. To add or subtract polynomials, you're going to add like terms. Okay, so for example, we're going to move right into the first example here. Combining like terms. So when we write, let's just write our steps out first, how we normally do. So steps, we're going to write in standard form. Our second step is going to be to simplify if we have to, if you can, within, this means within the parentheses, I think that's how you spell it. But you're going to simplify if you can within the parentheses. And then the last step is going to be the combine like term step. All right, so now let's look at example 1. So we have 2x cubed minus 5x plus x. So we're in standard form, the terms decrease. In this one, we're not in standard form. So let's just rewrite. So we have 2x cubed minus 5x plus x plus, okay, the x cubed has to go first because that's bigger, plus 2x squared minus 1. So now we're in standard form. Now what we're going to do is combine or simplify in the parentheses. So we have an x term and an x term here. So we can simplify that. So we have 2x cubed, and then this would become a minus 4x. So a negative 5x plus x gives you a minus 4x plus x cubed plus x squared minus 1. Now we're going to combine all the other like terms. So we have a 2x cubed here and an x cubed here, which would combine 2x cubed plus the 1x cubed would be a 3x cubed. Then we have the x squared would be next. That's just by itself. We want to combine with anything, so we plus 2x squared. Then we have our minus 4x term here. There's nothing we can combine it with. And then finally, we have the minus 1, which that cannot combine with anything. So this would be our final answer. So we write it in standard form, simplify if we can within the own parentheses, and then you're going to combine like terms. Okay, so let's go to number 2. So in number 2, we have 3x squared plus x minus 6, and then plus x squared plus 4x plus 10. Both of these are in standard form already, so we can, and we don't need to simplify within the parentheses, so we can skip right to step 3 and combine like terms. So we have a 3x squared and an x squared, so 3x squared plus 1x squared would be a 4x squared. Then we have a 1x plus a 4x, so that would be a 5x. And then we have a negative 6 plus 10, so we'd have a, we'd have a plus 4 as our final term, and that would be it. So in this one, we could just skip to combining like terms. And everything's color-coded so you can see the things that match up. All right, so then number 3 here, this is a subtraction problem. So let's make a little side note. Right here, we'll make a little note. When you subtract, you're going to distribute the negative to every term in the second set of, and I'll just abbreviate, this means, oops, this is parentheses, okay? And we're going to also change subtraction to addition. So this becomes a plus. So let's look at this problem here. So we have a 4n squared plus 5, and then minus a negative 2n plus n minus 4. So we're going to take this negative and distribute it in, okay? So we would have a 4n squared plus 5. This would become a plus, draw a little arrow there, plus, sorry, the paper keeps moving. And then it would become a positive 2n minus 2n plus 4, okay? Now we can combine like terms. So the 4n squared doesn't match up with anything, so we could just bring that down, 4n squared. Next thing would be the n, and these n's, we have a positive and a negative 2n, so those are just going to cancel. So then the only thing we have left is the plus 5 and the plus 4, so they would just combine. So we have 4n squared and plus 9 as our final answer. So there is again. Sorry if I moved it too quickly. Just take a look at that. All right, so then on the next page, there's 3 more problems. I will do them with you. All right, so it's another subtraction problem. So what we want to do, again, in number 4, is take this negative and distribute it to everything in the second set of parentheses. So we'd have a 4x squared minus 3x plus 5. Then become a plus a negative 3x squared plus x plus 8. Now we can go ahead and combine our like terms. So I have a 4x squared and a negative 3x squared, so I'm left with just a 1x squared. Then I move to my x's, a negative 3x and a positive x becomes a negative 2x. And then a plus 5 and a plus 8, I would get plus 13. So that would be my final answer for this one here. So again, I'm just combining like terms. And everything's color-coded so you could see the things that would add up and match together. All right, let's look at 5. So in number 5, we only have 2 terms in each. So these are both called binomials. So we're just going to add how we normally would. A 1b plus a 4b would be a 5b. And then we have a negative 10 and a negative 3, so it would be a minus 13. So that would be it for that one. So 5b minus 13. And then the last one is another subtraction problem where we have to distribute that negative. So we'd have a p squared plus p plus 3 plus, and then become a 4p squared plus p minus 3. All right, so now let's combine our like terms. So I have a p squared and 4p squared. So 1p squared plus a 4p squared becomes a 5p squared. And then I have a 1p plus a 1p, so plus 2p. And then it looks like here I have a positive 3 plus a negative 3, so those are going to cancel out. So this would be my final answer. Okay. So that's it. We added and subtracting polynomials. Again, if you have any questions, please feel free to email me. Thank you.